right, this is the last lecture for this group of lessons. And what we're going to do is we are going to talk about how we can determine if something is a conductor, meaning it allows electricity to flow through it, an insulator, where it restricts the flow of electricity. If we go back one slide and we talk about electron flow, if we remember how electrons move from atom to atom to atom because the valence level, which is the outermost level, either wants to be completely full, which is 8 electrons, or completely empty, which is 0 electrons. So if it's a loose connection, that actually means that it's going to be able to transfer electrons from place to place to place. Do you think that's probably going to be a conductor or an insulator, something that allows electricity to flow or something that restricts it? It's going to be a conductor. So in this case, when we have one electron and we have copper, it moves relatively easy. This means that copper, which is a metal, is a really good conductor because it allows electricity to flow from atom to atom to atom. All right, so let's go through and let's talk about conductors, semiconductors, and insulators. First thing I want you guys to do is in your notebook, okay, and I'll get this little back, I want you to make a T-chart that looks like this, that has conductors, semiconductors, and insulators on it, okay? There you go. You want it to look like that. So as we start talking about this, you guys are going to fill in this chart. Okay, right now we're going to talk about conductors and insulators. They're the two most common ones. So in your head right now, I want you to think about anything that can allow electricity to flow through it. I gave you one. I gave you copper. Then I want you to think about an insulator, something that restricts the flow or does not allow it to flow easily. Chances are most of you came up with rubber, something like that. All right, so let's go through and let's talk about the differences, okay? So you're going to fill in your chart as we do this, okay? What about conductors? It allows electrons to flow easily between the atoms. Right here is the important part of that we've been learning about. It's the science behind it. 1 to 3 valence electrons in the outer orbit, which is in the outermost level, the valence level. So 1 to 3, because what do we know? It either wants to be completely full or completely empty. And 1 to 3 electrons, it's easier to get rid of than it is to gain, because it's easier to lose 3 than it is to gain 5. Okay? So it's a simple math game at this point. A low electronegativity, meaning it does not really attract them. It just kind of keeps moving. They're good conductors, things like silver, copper, gold, aluminum. These are your metals. Insulators. Electron flow is difficult between the atoms, meaning it does not allow it to flow easily. So if it's 1 to 3 for conductors, what do we think insulators are going to be? 5 to 8. It's easier to gain 1, 2, or 3 electrons than it is to lose 5 to 8 electrons. Okay, so it's going to gain them, but it's going to hold on to them. It has a high electronegativity, means it really tries to collect and hold the electrons, meaning it doesn't kind of push them out. Examples: mica, glass, rubber, plastic, anything that you can handle. So, for example, here I have metal pliers. Sorry, the end is metal. So when I touch it, it's a really good conductor. But if I'm going to hold on to it, do I want the metal to be exposed to my hand where it can shock me? No. So the handle is rubber, but the metal part is metal. So I can touch with something and allow electrons to flow through it without getting my hand hurt. You guys will see those types of things kind of throughout as we start talking about. This is stuff that you guys probably covered, conductors, insulators, in like 2nd or 3rd grade. We are just talking about the science, the valence levels, the electrons, all of that stuff. All right, so now what I want you to do in your notebook, you kind of already talked about conductors, semiconductors, and things like that. Come up with a list as much as you can, a whole group of conductors or insulators. So on here, you can see that the things that are conductors would be the pliers, would be the metal tips, all of those different things. What would be insulators would be the rubber or the rubber coil that's holding the wires and the rubber for the handle. So now your middle column, semiconductors, okay? Semiconductors are the ones that's in the middle. Remember, conductors are 1 through 3 valence levels, valence electrons, and insulators are 5 through 8. So what do you think the valence level would be, the valence number of electrons, so the valence electrons? sorry, that was worded funny, would be, it's the only number that's left. It's 4. It's the middle. Meaning sometimes it can gain electrons, sometimes it can lose electrons. It's the same. So it contains 4 valence electrons. Things like this include carbon, germanium, silicon. It's not a good insulator nor a good conductor, but it could be made a better conductor through something called doping. We're not talking about steroids. What we're talking about is like heating it up. Okay, so the best example I can give you, silicone kind of works very similar to something that you use often if you're doing crafts. Hot glue. Okay, hot glue in its original state is a kind of a solid piece of stuff, right? But what do you do with hot glue? You heat it up. And when you heat it up, it becomes very viscous and it allows it to move, right? That's why you can actually take 2 things, glue it together. It cools down and it holds. Silicone very much is used in the exact same way. You find silicone in what? Computer parts. You guys have heard about Silicon Valley in California? It's because it's dealing with digital technology and computer parts because there's so much silicone that was built in order or that was used in order to create all of those digital components. So what happens is when you're using your computer or whatever, when it's not on, the silicone is kind of chill, it's kind of hardened and it doesn't allow electricity to flow through it. But when it's doped, meaning heated up, that means it kind of starts to allow electricity to flow. Again, you turn it off, electricity doesn't flow. Heat it up, turn it on, it allows electricity to flow. If you have a Chromebook or a laptop and you put it on your lap for a while, you're going to notice it start to heat up. That's what silicone is really good for and why it's used in like computer chips and cars, all those different things that have it, okay? They're needed for transistors, microchips. It's used in electrical appliances. It's an insulator at room temperature, but it becomes a conductor when heated. So I'm going to let you pause and go back and fill in semiconductors, and at the same time, go back and fill in this information here on this slide right here. So go do both of those and then come back to me. And I'm going to move slides. So you'll have to do this on your document. Take notes. All right, we're almost done. So now what I need you guys to do is I need you to make another chart. You're going to do the exact same thing, but now we're going to put this into like terms that you know. So instead of using conductors, semiconductors, and insulators, we're going to talk about metals and nonmetals. So you guys are going to fill in the same chart. And I'm going to pause for a second. All right, so you should have a part in your notebook that looks like this: metals, metalloids, and nonmetals. Basically, when we look at our periodic table, it's broken down into these different areas. So all of these elements we know as metals. All of these elements that are in green we know as metalloids, and the yellow ones we know as nonmetals. Guys, this is conductors, insulators, the green is semiconductors. So we have a lot more conductors on our list than anything else. How do we know that? Do you guys remember when we talked about the groups and we talked about the number of levels? So if we have 1, 2, or 3 electrons in the outermost level, it's going to fall into that metal category. If we have 4, it's going to fall into that metalloids. If we have 5, 6, 7, or 8, it's going to fall into the non-metal category. So let's look at this. Same thing. So I want you to write this list down. Metals, they're good conductors. They're poor insulators. They're shiny, malleable, high density, have a low electronegativity. Metals, nonmetals, they're poor conductors. They're good insulators. They're dull. They're brittle, low density. They melt at lower temps, have a high electronegativity. Metalloids, they're solids, semiconductors. They're a combination of metal and non-metal properties. They conduct heat and electricity better than insulators, but not as good as metals. They're kind of the middle. So, in our entire giant lecture, I'm sorry that it's been long. I'm sorry that it's gone through, but this is really important stuff. And typically when we do this in class, it takes a long time. So we're answering questions, we're going back and forth, we're filling this in. Everything that we've talked about is leading us to be able to identify whether something is a conductor or an insulator. Okay. In our next big lesson, we're going to talk about electricity and how it moves. So we're going to talk about metals and how those electrons can move from atom to atom to atom and have it make sense to you. Hopefully this was informational. Hopefully, you were able to follow along as we go. This is brand new for us, trying to do a virtual lecture and still give you guys time to do it. You still have, after each of your lecture, questions to answer. So you still should have your notes. You should then be able to answer a whole bunch of questions. All right. So with that, there's Road Dog. With that, honestly, have a good day. We'll talk to you next time, and good luck.